All right, here you go. We're gonna do lesson 2.5, dilations. I can identify and draw dilations in the coordinate plane. So a dilation is a transformation in which a figure is made larger or smaller. And we would say that the original figure and image are similar. Okay, this is different from what we did with translations, reflections, and rotations. A dilation is a size change. Like I said, it's going to make something bigger or smaller. And an example of that would be, say you have a triangle with side 4, and then you have a smaller triangle with side 2. That would be an example of a dilation. We are not allowed to say that they are congruent. We have to say, in this situation, that they are similar triangles. All right, let's see how this looks as far as the math goes. So here we have a dilation, and it's going to indicate that the scale factor is k equals 3. They will use k oftentimes when we're talking about dilations. So when you see k equals a number, that will indicate the scale factor. If you look at these 3 points, 2, 4, -5, 1, and 3, 7, I'm going to take the scale factor and multiply each of those points by 3. So 2, 4 would become 2 times 3, and then 4 times 3. That becomes 6, 12. -5, 1 would be -15, 3. And then 3, 7, multiplying each by 3 would be 9, 21. If you are asked to write a rule for a dilation, you're going to see that you would just take whatever the k value is, and that's going to be multiplied by x. So I would call that 3x, and then also 3y for multiplying by y. So if you are asked to write a rule for a dilation, you're going to use it as a multiplication of the x and the y. All right, let's take a look at how to find a scale factor. So this is when the k value is not given to you, but you're given other information where you're able to figure that out. Let's go back to that triangle that I showed you earlier. So we have a triangle that has a side of 4 and another triangle that's similar to it that has a side of 2. And we're looking for the scale factor, the k value. So I want to find out, what does k equal? To do that, there's a formula that we can use. And the formula is, we're going to take the final side length and divide that by the original side length. And so in a situation like this, where we have 4 and 2, we would say that we're starting with the triangle with side length 4 and ending with the triangle side length 2. So the final side length would be 2 and the original would be 4. That would be my k value. Now, like any other fractions, we are going to want to simplify that. So 2 over 4 would simplify to 1/2. So if I'm looking for the k value, k would be equal to 1/2. That's the scale factor of that dilation. Just to give you another quick example of this, it doesn't have to be triangles. We could have a rectangle with side length 3, a similar rectangle with side length 9. In this situation, we are starting with 3 and then going to 9. So I'm going to take my final side length, which would be 9, and divide it by my original 3. 9 divided by 3 equals 3. That's the scale factor. That is the k value for that dilation. All right, one thing we can talk about when it comes to scale factors is what they do to whatever figure we're doing them to, like whether it's a triangle or a rectangle or any object. So we'll take a look at these scale factors and just identify whether they are going to make something bigger or smaller. Larger, we would use the word enlargement, and if it's going to make it smaller, we would use the word reduction. And basically all you have to do is look at the scale factor, and if the scale factor is bigger than 1, if it's greater than 1, like in this case 3.4, then it indicates that it's going to be an enlargement. If it's less than 1, So you have 1/3. That 1/3 is less than 1. That would be a reduction. So 1 is kind of the magic number that you're looking at. Some people will ask, well, what if the K value, what if the scale factor is exactly 1? Well, that would not be a dilation. It's not going to make it bigger or smaller. It's just going to keep it the same. So a couple more here. 0.4, that's less than 1. So that's a reduction. And then 100 is obviously bigger than 1. So that would be an enlargement. All right, let's take a look at the last problem here. And this is going to be more along the lines of what you would see on a test. You'd have to do something like this. And I just want to make a quick note here. I'm going to change this 2 units down. We're going to call that 4 units down so it matches up with what we have below. So first step is to take a triangle, dilate the triangle with a scale factor of 2, and then after that we're going to translate it 6 to the right and 4 down. So I have my original points you can see down here. I'm going to plot those points. So -2, 1, that would be A, 1, 1 is B, and then 1, 3 is C. So there's my original triangle. Now I'm going to take that original triangle, those coordinates, and I'm going to perform a dilation with a scale factor of 2. I get that from right there, scale factor 2. So I'm going to take these original points over here and multiply each one of them by 2. So A becomes -4, 2. B prime is 2, 2, and then C prime would be 2, 6. That is going to be my dilated triangle. This triangle should be an enlargement because 2 is greater than 1. So when I graph these points, I should see a triangle that's bigger than the one that I already have there. So here we go. -4, 2 would be 4 to the left, 2 up. There's my A prime. 2, 2, 2 to the right, 2 up. There's B prime. And then 2, 6, 2 to the right, 6 up. There's C prime. And make this a dotted triangle to just make it stand out a little bit. And as you can see, the A prime, B prime, C prime is definitely an enlargement. It's bigger than my original ABC triangle. One other thing I just want to note that I mentioned earlier is that these two triangles are not the same size. Therefore, we could not say that they are congruent, but we could say that these two triangles are similar to each other. To finish this off, we have to do a translation, and the translation is going to be x plus 6, y minus 4. So that's going to mean we're going to move A prime, B prime, C prime 6 to the right and 4 down. I'm just going to do it mathematically. I'm going to take all of these x values that I have over here, and I'm going to add 6 to it based on the rule that I'm applying. So -4 plus 6, 2 plus 6, and then 2 plus 6. And then I'm going to take the y values, and I'm going to take those y values and subtract 4. So I have 2 minus 4, it's -2, 2 minus 4 is -2, and then 6 minus 4 is 2. Those are my new coordinates. After I plot these, it should be the same size as my A prime, B prime, C prime, just in another space on the coordinate grid. So 2, 2, or 2, -2 would be right here. This is now A double prime. 8, -2, B double prime, and then 8, 2, which is C double prime. And then this is my final triangle. All right, good luck.